idea of mechanical energy. Mechanical energy is dealing with the energy that is related to movement. So when you have mechanical energy, it's going to be a partially potential energy and kinetic. And this is the little formula that outlines that idea, right? So it's going to be a blend of both potential and kinetic energy. Now, also as a refresher, the kinetic energy is the energy that results from actual movement. Potential energy is stored energy that is also related to movement. However, it is not in action at the time, but it is based on the height with respect to gravity. So in order for this to happen, if you have in this picture here, this bicyclist who's going uphill is doing work against gravity. As gravity is pulling this way down, bicyclist has to go against that, and that energy goes in, and that is in the form of work. It's just how this particular formula connects to the whole picture. Right? So the work goes in, building up potential energy, and that potential energy becomes kinetic. And as you know, the bicyclist will get faster as he goes down the hill, and at the bottom is going to be at the maximum speed, which means the maximum kinetic energy. So going over here to our picture of the roller coaster, we have our zero position here. Okay, so we say that this is 0 meters. Now, that means that at this point, because of the formula for potential energy, which it doesn't hurt to write it again, this potential energy is mass equals mass times gravity times height. This height here is 0, so then the whole potential energy is 0. All right, here is the maximum height, so then that is going to be the maximum potential energy. Okay, so that's a good thing to remember. The highest point in the system is going to be the maximum amount of potential energy. The lowest point is going to be the minimum amount of potential energy. Now, the potential energy and the kinetic tend to be opposites. So when you have the one down here on the bottom, then that is the minimum potential energy. And if it's moving, it's going to be the maximum kinetic energy. However, at this point right here, it's 0 of both. But when it gets over here, when it has the fastest speed, this is going to be the maximum kinetic energy and the minimum potential, right? And then that car is going to spend its kinetic energy and build back up to gain potential energy and then start to process again up here. Now, it does, however, going to lose some energy due to friction so that it comes out of the system in heat, typically, and sound. That's why this hill on the other side has to be lower than the original hill. Otherwise, it's just not going to make it up that hill because it doesn't have enough energy to do so. So, and this is the big picture summary here. Understand that the mechanical energy, the energy from the movement, is a combination of that potential and the kinetic. There's pictures down here show that there's a couple different ways to develop potential. Right? You can go against gravity, and you can pull against maybe an elastic, or push against a spring, pull against a spring, and you're going to build up potential. We're not going to deal with that right now, but that's something to look forward to in the future. If we go to your second thing of notes here, we have kind of the mathematical application of this. Now, we're here for the skateboarder at the 0 point down here. This is going to be where it is at 0 meters. All right. Now, how do we know that? Well, because that's the minimum. So that's just where we pick for 0 to be. right? And we also know that this is 1 meter. So if this is 0 down here, then this will be the height of 1 meter, right? And we can figure out the rest as we go. Now, these three formulas, keep all three of them in mind. They're going to kind of interplay together, and we're going to see how they interact. Now, here, since he has 0 height, the potential energy is going to be 0 joules. Again, 0 H, no matter what M and G are, that potential energy is going to be 0. Now, for the kinetic energy, we do have the information here to figure that out. So using this formula, then kinetic energy will equal 1/2 times his mass, which is 60 kilograms, and his velocity, which is 8. Oops, gotta put my units in there. Hold on. Meters per second. And we're going to square that whole thing. And once we do all the calculations for that, we will find that that is 1920 joules. So then that's what goes here. Now the mechanical energy then is going to be the total of this. And we know that this in this case is 0. And this is 1920. So 0 plus 1920 is 1920. All right, so important point here. Make sure that you understand this. When you are in this position right here, whatever energy goes in is the energy that the whole system has throughout. Right? So the mechanical energy of the situation stays the same. It may be all kinetic, it may be all potential, it may be some of both, but it's still going to be 1920 throughout. So just to keep that safe and sound in your brain, I would go ahead and just write 1920 here and 1920 here. All right, this is all from the conservation of energy. The energy is not created or destroyed, but it can be transferred back and forth. Now, in reality, you're going to lose some, right? That's going to leave the system in from heat, from sound, those sorts of things. But we'll pretend to have an ideal world here, and we'll just kind of go with it. Now, in this number 2 position, I'll just write number 2 over here and do it out here. First thing is potential energy. Now we have a bit of height, so we can solve that. So the potential energy is mass times gravity times height. So then the potential energy is going to be his mass, which is still 60 kilograms. He hasn't lost any mass that we know of. The gravitational pull, going to use 10 meters per second squared. You can use 9.8 if you want to be super exact. Then we know his height here, which is 1 meter. So we're going to multiply that guy up, and we're going to come up with 60 times 10 times 1, which is 600 joules of energy. So that's going to be the potential energy right here. Oops. Jumping the gun there a little bit. 600. Now, it's not going to be a super hard math problem to figure out the kinetic energy, because the mechanical energy and the kinetic energy are going to be added together. We know that the potential energy is 600. So if we have a total of 1920, that's going to be the kinetic energy plus the potential energy, which is 600. We do that math, we can figure out that the kinetic energy is going to equal 1,320 joules. All right, so we put that in there. Now, becomes a bit of a question mark because we had to find velocity, but we do know that velocity is part of this equation right here. So what we can do And some quick algebra magic. See, I had that hidden there. We find the velocity by doing some rearranging of that formula, and we get the velocity is 2 times the kinetic energy times the mass. Or I'm sorry, 2 times the kinetic energy divided by the mass. Take the square root of that. So then the velocity is 2 times 1320 120 joules divided by the mass of 60 kilograms, and then take the square root of all that, and your velocity should end up being about 3.3 meters per second. All right. So you can do the calculations on your own. That's what I came up with. So velocity here is 3.3 meters per. Still can't write. That's all right. Second. Okay. Okay. So last part for number 3 here. Again, we know that the mechanical energy is 1920. Now, this is the topmost part of it. So what happens to the skateboarder when he gets up to the top? Well, he's going to stop, right? If you've ever seen this happen, you know at the top of that half pipe there, he's going to stop at the top and then come back down. So if his velocity is 0, then the kinetic energy will be 0 joules. So all of that mechanical energy then will be 1920. So, and the velocity here will be 0 meters per second. So we have everything solved except for the height. Now we'll go over here to solve for the height. So potential energy is mass times gravity times height. And potential energy divided by mass times gravity is going to equal the height. So now we just plug these guys in. We have 1920 joules. We have a mass of 60 kilograms. And we have gravity of 10 meters per second squared is equal to the height, right? And so then 1920 divided by 600. Let me go to my calculator right here real quick. So 1920 divided by 600 is 3.2. So we got about 3.2 meters of height. I'll do it a little bit better. All right, so that's the basics on how to find that. And so what I want you to do, your homework for today, for the next class, is going to be similar information, and you're going to have to go through and solve similar situations. We'll do these next couple in class on Thursday, and let me know what you think. And if you have any questions, I'll be happy to answer them. Sorry about today's class. Hopefully this will help, and we'll talk to you all soon. Have a great night. Bye-bye.